exciting, fun. Since architecture is not exactly the most sexy thing to talk about, I got nothing. So let's just keep going. But on that note, so I thought I would first do is just talk a little bit about a little of my experience getting into Unity, mostly AR, VR, and maybe they'll give a little background onto why I chose some of the architectural ways I did. So I've been doing software for a while. It's been about, my first 20 years were just really working on robotics and navigation for some big companies, working on some projects. And I was really trying to come up with, what new piece on the software could we try to patent, or, any part of the project. That's what big companies like. So I got a few patents. But then on July 28, 2016, something happened to me that changed my whole entire career. So when I was working at Ostrom, we were making the components for AR, VR headsets, the little sensors, proximity sensors, eye tracking sensors. Anyway, so the guy next to me had this big vat of all these AR, VR devices. I'm like, Joe, what is that? He goes, these are all the new headsets. It was the Oculus One, HoloLens. Anyway, I put on them. One time I was in Tuscan Village. Every time the HoloLens, I was, doing some cool stuff. So I go, and this is the future. So after that, I just knew it. So let me also, a little caveat too, a little flashback, my 1992. So I was, when I was at the University of Illinois, I like to tell this story. I was next to Mark Andreessen. He's famous now for Netscape. But anyway, he was doing the first browser. I was designing some of the first web pages. And I told my parents, I go, should I just drop out of college and just do this? Because this is going to be hot. I can just tell. Like, no. College degrees are most important. Anyway, this guy goes on next year getting $25 million through Netscape. But I did get my degree. So my point here, though, is I was ready for the next big technology evolution. I wasn't going to miss AR, VR. So I told the people at Ostrom, I said, give me some money. We'll make a cool product and we'll make lots of money. So this was the vision. Putting AR headsets or mixed reality headsets on people in construction. So when we install our products for Ostrom, they do a lot of lighting and sensor stuff. They knew exactly where to install them. So for like a year and a half, I just really dove into Unity and put every single feature I could possibly think of in this HoloLens application, mapping, gesture controls, navigation, everything I possibly could. And this is my picture. I was wearing sunglasses because my eyes were like tearing so hard after like just working on this for like a year and a half straight, like weekends, nights. So we were so excited to finally like publish this. We went to a construction site in downtown Boston where they're putting a new school in, and we got, no one was going to put a headset, mixed reality headset on, and they definitely didn't want to. No manager was going to spend the money, so it was a huge fail. But couldn't get everyone disappointed, so did the whole entire thing over again, AR Core, because they all had their phones, and they said, "Woo, yes, we'll do the phones." So I did the entire app, this time using Bluetooth triangulation, even communication with the lights. And they did enjoy pieces of it. It was a mixed success, but it did allow me to go on to other things. So I started working on Point, where we use mixed reality headsets to let the doctor know where to apply their tool. So it tells you exactly, imagine they have their HoloLens on, and allows them to line up their tool in exactly the right orientation to start drilling or pressing in. And then also led to my next one, which I'm at right now, Immertech. These guys are just really high energy company that I presently work for. And the same type of thing though, but with virtual reality, where you have either someone training to be a doctor or another doctor off site, and they want to have this immersive experience of that they're actually in the surgery room. I will admit this was a bigger advantage over no cadavers, so I like this position. But this is all in Unity and using the Oculus Quest. So I found in my last flashback. But the reason for this whole thing, the whole presentation, was in 2007, when I was first in my first Unity project, This is basically what it was. You looked at the insides of it. It was a complete disaster from an architectural point of view, just from everything. And this work starts getting controversial, but what attracted me to the Unity, where I started with Unity, was what they always have attracted beginners with, which is all the visual pieces of it, visual scripting and everything. And I was kind of on the other side of things. I was using very traditional tools, traditional frameworks. And so I call it the Great Divide, where I was constantly always, fighting with it. But anything, I want to make cake and eat it too, right? So the answer is architecture, which is presentation. So I was just going to go in this presentation just to go through, where the Unities right now in their framework. Some things I added to it, which hopefully maybe someone will find fun or entertaining or useful, which will cover like Finite State Machines, model view controller, and services, and then put it all together. So here we go. So everyone knows Unity. They have their typical EC, entity component framework, not to be mixed with ECS, which I don't know when that's ever coming out. But anyway, you have your scene, which is like your game level. Then you have your entities, the game objects, and you add components to them, and then your game object becomes something. Like you add a render and a mesh, and it becomes a cube, right? And it's really nice. You can drag things in and out. I'm not telling you guys anything new here, which is fun, and it has that visual thing, but it does tightly couple everything together. And what you kind of end up with along the visual scripting is when you try to do a diff between commits, you get those very, I don't know, the best thing I could say is like the Matrix, right? I don't know how to read it half the time. Maybe I'm just don't want to. I don't know. But while all these tools are nice to do to get your project going, I find it kind of hard to maintain for enterprise point of view. So okay, maybe this is where Unity pulls the plug on this presentation, but I'll keep it going. But there's some good stuff here, promise. So anyway, the answer, of course, is a custom architecture that really helps your own game. So you're looking at the goals for an architecture, and it's really, flexible code flow. You just think about different levels of your game. You want to be able to interchange them sometimes. You also want separation of code. So we have multiple people on our team. We have one person that just works on more of the UI, the views. Some people work on the back, I call it the back end, but more the logic. And then you also want to kind of isolate your data. So having good separation of code in your architecture is important. If not, you're just keeping people from tripping over each other too. Loose dependency. So when I want to get a file from the cloud, I just want to say get file from cloud. I don't want to have to specify right away, early on, use AWS. Maybe I want to use Azure later, So it's just a loosely dependency in your code. Programmatically create a UI. So this is one of the part I always, whenever I get a new person Unity on my team, I tell them, hey buddy, we have one scene, we have one user game object, and we have one script on it. And this is where everyone goes, what are you talking about? You're killing me. And it just, we never have seen conflicts with merging. But no, we heavily use prefabs. So we do is programmatically launch prefabs, and we use our finite state machine to go basically from one state to another. And I'll show some advantages of that. I'm not saying you should always do this, one scene, but I think there's some advantages of some advanced architecture over a lot of scene messes. But yeah. And then we also have decoupled services. So I try to make everything in the game or application a service. So whether it's a pathfinding service for a player, just a database service, something that just works with the file IO. So basically you're trying to get your code as modular as possible. And then that also keeps people from tripping over each other. And then multi-threading. I think if you create all these discrete services and you put them on different threads, it just runs everything a lot more efficiently. Assuming you can do some multi-threading properly. But I've just noticed huge efficiency gains from the app, frame rates and everything. And you have everything on multi-threading. It'll all be on the same core, but That's a Unity problem. Okay. So how do I solve these? With the flexible code flow, using finite state machines, where the code goes from one state to another that can easily rearrange. And there's always there's different conditions going each one. Separation of code, model view controller. This is kind of a default for any .NET application. So it's kind of the de facto for a lot of the Microsoft things. We're really just separating your code from your view controller to your data with your model. To reduce a tight dependency using dependency injection. And I'll go through this a little bit later too. It just allows us to make decisions about what exactly is the exact implementation of some of these classes that we want to do. For UI creation, we have a pattern. We use a factory pattern. So basically populating prefabs when we need them and destroying when we don't need them. Decoupling services using events so that I can broadcast an event and have a callback being fired that subscribes to it and it fires it. So we don't necessarily have this tight coupling of the code. And then multi-threading. This is because you have to deal with the threads from the Android. Well, if you're doing VR, you have the main thread and then all your service threads. So that's the architecture in a nutshell. I thought I'd kind of dive into some of the specifications. So, finite state machine. So I just have this as like a little intro slide. I'm sure a lot of people know finite state machines, but basically you have different states. So imagine your life, right? You have a state where you're in bed. You have a state when you're home, and you have a state when you're in work. And you always have these conditions that take you from one to the other. But the beauty of this is that once you're in one state, you don't have to worry about things you normally worry about in other states. So if I'm at work, I don't have to worry about annoying neighbor at the door. So from a code point of view, I can just concentrate on certain events. I don't have to worry about other ones. So your code can remain isolated and focused. And this is important so you can reduce a lot of the if-then statements and keeps it, everything's very isolated with the idea that you're only in one and only one state. That's kind of the principle of the finite part of it. All right, so how does that work for a game? So you can imagine, one stage you're running, another state you're paused, and you're game over. And the condition for game over, okay, the player dies or wins, right? So you can see the conditions. And one thing I liked about the finite state machines is we added another level to it. So we have a second level. So imagine now you have like two finite state machines running embedded in one inside each other. And this is where I think you can get a lot of extra flexibility. So when your game is running, your player is either, maybe it's in the forest, it's in the castle, or in the cave, but only one of those states. So when you structure your code this way, I think it really has that advantage over scenes that I can nest these finite state machines. I can easily, rearrange them easily, and then objects persist between the different states, and I can control my memory scope. So imagine kind of like an advanced scenes. The disadvantage of those, of course, I have to clean up, and it requires me to instantiate this framework. So this is the app that we're currently working on. And like I said before, it's, someone joins, almost think about a Zoom call, but 3D in VR. That's basically what it is. So everyone else joining can hear other people. You can't really see each other. You can only see the person who's giving the surgery or in the medical room, but it's very much a peer experience. So here's a really simple state machine of that code. Our state machine is very much higher, a lot more complicated than this, but I wanted to give an example. So it launches the application. We check Android permissions. Then it's, welcomes you to continue. Make sure you have network. Then if you're authenticated with the system, it puts you into the live event. And once you're in the live event, You can, communicate with everyone. You can zoom into different cameras. You feel like you have this immersive experience. So like I said, the cool thing about the states is once I'm in the live event, that's when I care about the live, all the things that happen for a live event. I don't care necessarily about things from other states would care about. So it just makes everything very segmented. Kind of feels like a very small scene manager to me. All right, so since this is a software presentation, I thought I'd throw some code up there. So each state has a typically, it looks like a little bit like a mono behavior script. We have enter, update, and exit. And that's on purpose because I think that's a really good pattern. And then typically when you enter a state, you want to throw up a view, prefab. You want to subscribe to all the buttons. I don't like putting business logic in the buttons. And then the callbacks typically would transition you to a different state. So if someone presses a button, enter, the callback puts you into the next state. That's a really easy example. And then when you exit, it cleans up everything. So let's see there. So as far as like the actual finite state machine itself, it just holds the current state is one and only. And it also, its parent, if it has a parent finite state machine, and its collection of states. So from this point of view, you can easily say, hey, where are all the states? What's the flow of the program? And how do you flow from one to the other? And typically, the pattern in the code in the states is just the transition stuff. So you can really clearly see how the code flows without having to dive into a lot of other code. And it's got the methods that make sense. I'm adding states, transitioning states, and then doing an own update. So, all right. So moving kind of along. Hope you didn't lose anyone so far. But now with the model view controller, like I said, this is a way of segmenting up the code. So I have my own little spin on model view controller. Typically, your model a lot of times has the best way to say the functionality to bring in and out of data. But this was the one that made sense to our team, where the models just pretty much controls the global data. But the services would actually have the database functionality in it, among other services. And then we have the views, which I said, like it's like your UIs. And then the controllers are typically the business logic that's in all the states. Right. So let's see. All right. So this is what this looks like in a big pattern, that you have your controllers only talk to your models. It becomes like the bridge between everything. Your views never talk to your models directly. Your services don't talk to your models directly. And you kind of has this flow. So there's always a control by the controllers. And we'll dive into each one of these a little bit too. So like I said, the models are really the UI. It's the prefabs in Unity. And we try to put as little code in there as possible. So it really contains no business logic. It doesn't really want to store any data. And it's not really scene specific. They're just like, you imagine a prefab, very isolated. And therefore it's very maintainable. Someone could work on a prefab, merge it back into the project, and it's most likely someone else is not working on that exact prefab. They're probably just working, which we always had that problem with people working on visuals in the scene that they try to merge it back in. It was very difficult. And a little best practices. I always use Text Mesh Pro. Our graphics use bitmaps and aliasing. And we do use a lot of prefab variants, but try not to overabuse them. So this looks like our review factory, where we give it the name of the prefab we want to add into the scene, the parent and the position. And then usually as soon as we launch it, we would subscribe to all the buttons. So this is just an example of subscribing to the buttons. And then all the actual button logic is in the state, what did it actually do. The only script we put on the, well, every prefab has what we call the holder script, which has links to any of the game objects inside that prefab that we want to interact with. Most of them being buttons. So it kind of keeps everything on one level. So people, you're never diving into into embedded children game objects to get certain components you want. They're all brought to we call it the top level service. That's helped a lot. It's like our interface. And then controllers. So the controllers, like I said, is kind of the business logic inside each state. It has it's usually either in the enter, exit, or update states. And it usually it usually manages the flow of the code and stores any of the data. So best practices, if you are going to have data, if you change a transition from a parent state, a lot of times will erase the children states. So you want to make sure to put the data at the lowest level finite state machine that you need it. So just minimize the amount of global data you're constantly always using. Make sure I always write the states interchangeable in case you want to rearrange them. And whatever you possibly can, put into a service. Not quite yet. Next. And as far as models, so models are act like a local database. They really want to store data. Think about it as like a high score in a game, where it's something you want to just collect and have access to from different parts of your game. So we have kind of scoped and global ones, but if you look at the memory space in general, the finite state machine states have their own local ones that may be shared for all the states in that finite state machine level. And after that, we have models that are kind of created and destroyed at a higher level. And that would be containing any data we might need. And then we have the ones that pretty much are always there during the entire game. And those are global models. And they only reset the app reset. So this just puts, allows you to really scope your variables. So we always keep minimal data memory space. All right, now it's the last piece of it. Services. Just keep you awake. Sorry. Okay. All right. So services are really, how do we, keep code very isolated? So for instance, we don't want to have a lot of cross-contamination or dependencies. We want to keep things in their own little islands. So I gave these examples before of, I want to do any file IO, it's going to be a service. If I want to be streaming data through multiplayer for multiplayer gaming, that's going to be its own service. And so each service has a start and a stop. And then we can, and the great thing is too, by making this isolated thing, we keep everything in its own namespace. It's very easy to reset. And Unity has some greatness as far as, you can do assembly definitions to either further isolate it. And if it's a big service, you could even make its own repo and bring in as a, sub repo. Some of the best practices here is, the services typically have their own threads. I think this is really great for efficiency. I say no coroutines, but sometimes it's good. If it's something that's very related to mono behavior, I think it works out well if you want something that's easy to stop. Otherwise, we try to use a lot of async with a cancellation token. It just keeps it away from the mono behavior as much as possible. That's why I try to avoid, just makes the services smaller. It doesn't bring in so much other things. So I try to tell people, hey, let's not use any Unity APIs in the services. Some of the best practices, definitely use concurrent collections. Do a tutorial on that. take whatever he needs to do to understand how that works for multi-threading. And I'll go this when we're putting it all together, but we also have create queues so that the main threads can talk to these other threads. But within the service, we have, like I said, the service start, service stop, and then some type of response type to know if it's running or not running properly. All right, so this is the cool thing I think about services, which everyone should understand if they haven't understood already. So let's say I was doing a typical object-oriented design, and I had this cloud service, get file. And I did the right thing. I made an abstract class, and then I did a specific one for AWS and a specific one for Azure. Okay, that sounds makes sense. Then inherit from the cloud service one. And then if I want to use the AWS one, I can make an instance of the AWS, reference it by my parent class, the base class, and just call it by the base class. And if I don't really need to change too much code, I just need to change how I create that first object, the polymorphism. Now, if I want to change it to Azure, all right, I got to go through and change all the AWS to Azure instances, and it'll work. But I do notice that they had this is sprinkled throughout the entire code. I'd have to do a lot of code changes, and it feels a little bit tight. So here comes dependency injection. The dependency injection is a design pattern in which an object or function receives other objects or functions that depends on. A form of inversion of control with dependency injection aims to separate the concerns of constructing objects and using them, leading to loosely coupled programs happens automatically. Well, I know that's about as confusing as Bitcoin miners wearing hard hats. So I ended at that. But I will give you a clear example. Hopefully it makes more sense. I can't believe this is actually a picture, by the way. I mean, they're probably constructing something, it probably makes sense, but okay, so instead, make an interface of the iCloud service, and then I'm going to use the interface and actually implement it where I have one for the AWS and one for Azure. And then I come in here and using dependency injection, I say, I want to bind something. That binding just kind of makes me two things equivalent. So basically, I'm going to bind iCloud service to AWS. Now I just call by the actual interface. So you can see a little keyword inject. So it says inject something into that interface. In this case, I'm going to inject the AWS class. And then the rest of the code seems fine. But now let's say I want to do Azure. I just have to change this one binding. Now this one binding is just one file that's just for the entire project. So I just have to change in that one spot, and there's a whole file, just a file with just all the bindings in there. And I just have to change the one spot. My code doesn't have to change at all. So now I've completely changed what cloud service I use, but just changed one spot in code. So aha. Beautiful, beautiful. So that's what we do, where all the services get injected with the exact implementation. So therefore, we can change any of the type of details we want, whether it's a different cloud service, for file I/O, maybe it's a different library. We have a video play service. We can use a different thing, whether it's AV Pro or some other type of asset. So we can easily swap them. So it becomes a nice. All right, putting it all together. Everyone's still awake. All right, just a couple slides here. So I said, we only have one scene. We actually do have two scenes. We usually do use an init scene, and that's just stuff we want to load before the camera loads. So some of that stuff is just easier to put there. And then within our actual scene, our application scene, we have two scripts. We have one that just starts the finite state machine and all the services, and the one that's just to deal with the dependency injection, so it has the bindings in there. And really, so there's no other game objects except for the one, camera rig and the manager. And then once we start the finite state machines, it's like a big monster just goes and creates. At any one particular time, we could always jump into any of the states for testing, or just jumping right in there. So that makes it kind of nice there too for testing. Oh, and I didn't tell you about services. That's another thing too about having the separate services, is we have test suites just for each individual service. So they kind of test themselves. I was like unit testing, but this is a nice way of keeping the test there without having to go overboard. All right. And here we have how we connect, kind of alluded to before, where we have all these services that are all in their own little threads. They're being injected with dependency injection on which specific code to run. They're dumping stuff into a concurrent queue. And then the finite state machine is pulling from that queue, running in the main thread. And this is how we kind of communicate between the multi-threads and Unity's main thread. And then that calls the Java thread, Android thread, if you have a Java application, which is pretty much everything now for augmented reality, virtual reality. And then we have a collection of things that I mentioned before, which are like tools that we can just, they're independent of everything. They're just simple ones like, math tools and stuff like that. So we go back to 1992. Why didn't I go off to web design? I was just waiting for AR/VR. And thank you. And then so we are hiring. There's my hiring slide. There's the link. Should probably throw my contact information somewhere, but I can put it on the jobs post as well. All right, I just realized I kind of flew through that like super fast.
That was great.
Okay.
Yeah.
All right, good.
Cool. We get a couple of questions.
All right, super.
Yeah, if you want to take those. So USEF 15015 asks, excuse me, for global models, where do you store data that is not currently in use?
Well, yeah. So, like I said, we have the kind of the three tiers. We just have, well, I mean, I guess currently in use is, is that like I just need to store it, but I'm not need to access it right now. But it's like, okay, like highest game score, right? I don't necessarily want to destroy it, but I'm not using it right now. If it's something that I don't, so I like I said, the rule of thumb is always to put data at whatever level you absolutely need it. If you don't need anything higher, then don't put anything higher. So the finite state machines constantly create and destroy their states. So it only put it there if you need it there. If you need it more of a persistent, then I would put it into the model. And then the model you could store if you want into a database or something too, if you want to persist it through even app starts. Or we send a lot of stuff to the file, right to the file system. Of course, that could get overwritten too with installing apps. I don't know if that answered the question, though. I don't think it did.
If it didn't, just throw some more follow-ups in chat.
Yeah.
But I actually have a question about services, which is interesting architecture. I've sort of seen pieces of it before, but I haven't really seen it like described as holistically as this, which I really like.
Good.
Yeah. So like, do you have services that talk to each other? And then if you do, how do they maintain that dependency, especially with regards to testing?
Yeah, that's good. That's a good point. Do my services talk to each other? There's always, with every architecture, there's always some holes that we always have. And
sorry, I don't want to put you on the spot.
No. There's always some business logic that didn't quite fit into any nice bucket. And I think that's kind of where that's alluding to, where we had some services that needed to be persistent through a lot of different states. But they were kind of specific to a specific scene, shall we say. Or not a scene, I guess to a specific view. So there was a little bit of that issue. I mean, you could argue that if you properly design your services, they shouldn't really need to talk to each other. And really, the controller is really the bridge between the services. So the one, you're going to be sitting there with your callbacks in your controller and saying, "Oh, I see that you lost network." Well, I'm going to talk to my other service about streaming and say, shut down. You lost network. So, hey, let's try to gracefully shut down. So really, your controller is kind of your operator between your services. And if you do need to, I mean, we all the time, I guess, get information from one service to the other, but the services don't really know about each other, right? So if you wanted one service that connects to the internet, okay, I make sure that service is done. It tells me I'm at this Wi-Fi SSID, and then I might give that to the other service that uh, does some transmission of Wi-Fi credentials to another app or something. So there's typically not an overlap if you do it correctly.
So this kind of leads into a question that someone typed where they said, I may have missed it, but could you talk more about events, subscribers, and callbacks for decoupling in Unity? Which I wonder if your services are listening to each other through this, or?
Yeah, exactly. Yeah. Let's see. I think I have a slide on that too. Well, this is not the. So I had a bigger presentation at one time that had more confidential stuff in it. So I kind of took it out, but I'm just realizing that I think that's where I had some of this callback stuff in there. Okay, well, I'll try to describe it. But when we set up a service, it's going to have it's usually sitting there and I get a little separate island and it's running. And then when I create the service, I'm going to say, hey, when the service fires all these events, I'm going to have a callback in my state that's going to react to it. So for instance, my service might be authentication service, right? And it's going to broadcast the event that says you've authenticated. Well, I'm going to subscribe to that event in my state when I enter that state and say, okay, when I'm authenticated, great, go to the next state. I'm ready to go. I think I may have mentioned a little bit in this one slide, wherever it was. But anyway, so, and that allows that coupling there, but it also keeps things separated. So it's a lot of subscribing to events. And if I wanted something to happen, if the service wanted to do a command, something directly in the state, then that would be putting that command into, we call it command queue, which is just a whole bunch of delegates that basically I can just command stuff right into the program itself. So there's a little bit of that, hey, the service can control something in the state besides the state's just reacting to events it gets from the service. Mm-hmm. If that makes any sense. I know I had a better flow for that here.
This is skipping a little bit, but someone just asked, how do you set up event channels? Do you use scriptable objects for event channels?
I don't use scriptable objects. I probably should, but I just simply use a Unity event. Mm-hmm. Unity action. And that allows you to, put your own parameters into it. With the command queue, I just use generic delegates. I think I had for this type of thing where I'm just, controlling stuff back into the state. And I haven't really I know some people said they've had some problems with Unity events. I haven't had that issue, but I don't know, maybe I try not to ping things too fast from the services that the states are listening to. Yeah. So it's more like triggers to go to different states than constant data flows. If you're constantly looking for data flow, I would have all that being listened to in the actual service. The service would be constantly dealing with a stream of data and needed to process that data. Apologies, I didn't have that slide. I took that slide out about the whole Unity actions. Shouldn't have.
This leads into Jesse's question about, do you store references to data models in global scope somewhere to prevent states from having to read from file every time you need it?
So, okay, I kind of understood path of question. Say it one more time. Sorry, one more time.
So, do you store references to data models in a global scope somewhere to prevent states from having to read from file every time they need it?
Okay, yeah, it's the file, I guess, that's throwing me off a little bit. Yeah, a lot of times we'll load, if it's the file, I will load from the file to the global, the model, usually at the startup of the application. And then I don't really read from the file anymore until I have to update it. So the file is just there just to help with, restarting the application. If the application crashes or I reinstall it. So I don't do an uninstall. And just so personal preferences, shall we say. Otherwise, everything is kind of stored, outside the file system, just in resident memory. And I try not to put much. We don't try not to put much in global models for that reason, because you are just hanging on to these things too long. And I try to put stuff in the different states in the finite state machine level for that reason.
What's an example of something that you put in the global model versus a states model?
Yeah, well, good question. Yeah, I say high score from a game point of view, but what are some of the things? So there's a little difference between two from a global model, and let's say just settings, right? So if it's just I guess we do have a file of just settings, but these are things that we know you don't really change. So the global model are things that the application wants to change and store. So I think of some of the ones that we would have that aren't so specific that wouldn't make any sense. I was just trying to think of
I mean, settings makes a ton of sense. Yeah, like preferences, that sort of thing.
Yeah, the actual settings, yeah, I guess if the user changes a preference, it's fine. But if we get a crash, we might store how many retries we did. If we or how long the person's been in if they quit, how long they were in the event for. Just something that you might want to go back, go through all the states again, go to different finite state machines. You don't want to lose that information. Yeah, so I don't know. That's the best way to say it. I know people give me the example of high score before, but that one always makes a lot of sense. Yeah.
Do you have applications that you've built that handled sort of different platforms and SDKs? I mean, you mentioned like iCloud versus whatever, but like for XR, like are you using XR Manager and then depending on some situation loading the Oculus plugin or OpenVR and all that stuff?
This is painful. I think my left arm's starting to have it twinge. Just talking about the ways of doing these multi-platforms. We spent like months trying to figure out the best way to do this. Right now, we're using the Vive input utility, which I can't say I really recommend it right now. But we're going to. So the thing is, at the beginning, we were trying to support all these different VR headsets. And we're talking kind of, specifically all for the XR industry here. So we had the Vive ones, we had the Oculus ones, we had Picos. And so, what do you do with that? We had the XR Interaction Toolkit, which is not bad. We had some issues, using that in terms of there's just some certain things in Oculus that we wanted to use that just had a hard time using. It certainly does have hand tracking. It was just everything was smoother and seemed to track better if you just used the own Oculus SDK. But then now you're kind of pigeonholed into just using Oculus. But so this was a constant battle, right? Yeah, you definitely should use OpenXR, but that's kind of the wave of the future. Don't use any of the legacy code. So that's for sure. Well, how do you handle different platforms? And now if you're not talking about VR and AR, you're just talking about like iOS, Android. Well, actually, I guess that's pretty straightforward. It was just mostly the how do you deal with all the different Android devices out there. So our plan is, if we stick with Oculus, probably just use the Oculus SDK and their own tools. But yeah, for long, like up to this time, and we're still using the Vive Input utility. I don't know if you guys know that one too much, but it's their platform switcher. So they support Oculus, Pico, Vive, of course.
Mhm.
And it's very much like the XR manager where you just select which one you want.
Okay.
And it was really cool for a while, but now if you switch different, it rebuilds the whole project. Well, I guess rebuilds not the right word to say it. It reconfigures the whole entire project. We used to not have to do that. So that's been a little challenge switching platforms now. But yeah,
Yeah, I
there's
do a
some
lot
trick.
of
I'm sure there's some tricks there we haven't figured out.
right. I mean, I feel like using if you stick with the XR interactions manager and new input system and stuff like that, and take the time to customize everything, you can get pretty good. Like the it comes to build time when actually like SDKs would get swapped out and all that. But yeah, I was
We,
wondering
we
what
just
you
had
could
some
do.
funky things like the raycast was looking vibrated a lot. We just kept running into some funky little things like that, which we were making custom scripts for to help. But I feel like when you have one tool that does everything, it does
Yeah.
everything okay.
Right.
Yeah.
We have some other questions we should probably
Oh, sure.
get at. So, so Pine JH, Pine JH, sorry, um, says that I've seen scriptable objects can be used for easily accessible and modifiable data. Do you think that they could be used for keeping this global state? So I think you maybe touched on that earlier with talking about scriptable objects, but
Yeah, yeah. I don't really use scriptable objects too much. But yeah, there's probably something there you could definitely use. That's kind of been in a nice, Udemy add-on, kind of bridge the fact between something that's customizable yet still staying in the Unity space. Um, but yeah, I try not to use too many Unity UI tools. That one's not too bad, but some of the other ones are just difficult to keep with a repo. Looking at, you have different commits and trying to figure out what's been changed from commit to commit.
sure, yeah.
Yeah. And
Um,
it's tough when you have a big Unity team.
we do have a pretty excellent talk on scriptable objects and software architecture related to that by our very own Chris on our YouTube channel. So definitely check that out.
Yeah, should do
Um,
a good job on that one.
cool. Yes, Vendals are Vin. Oh, sorry, my text is so small. Vindolis asked, I totally understand these architectures are important for larger projects and especially for software that's maintained for a long time, but how applicable do you think these are for smaller indie titles? Games are more fire and forget, where the extra effort to some of these things might be overkill.
Yeah, no, it's a good question as well. I don't consider the app that I'm working on as like this huge monstrous project, but it does have a lot of extra components that you wouldn't see in games. I think it's got like a big streaming component. It's got a lot of networking capabilities. I mean, we're streaming like a 6K video with zero point 0.4 seconds latency, which is like incredible. So it has a lot of things that I think a typical game wouldn't have. So I think that's why we're using some of the enterprise solutions. But I will say when I started with the team, they had very much just a typical Unity thing. It didn't take too long for it to really become unmanageable. I mean, if your game is highly just graphics and game objects and such, maybe you don't need to. But if you really are using some type of networking services and other components, it's nice to be able to segment things together. And my guys know exactly where to put new code. And I think it just helps with that too, especially if you have more than one or two people developing your game. It's nice to have these different buckets where people can play in without, stepping on other people's code, which always causes merge problems. And
Mm-hmm.
it doesn't take too long to get spaghetti code.
You can say that again.
Yeah.
Could you kind of describe how like artists or designers would work on like your UI?
Oh yeah,
Um,
yeah. Oh, that's the one thing people really like about this architecture is we have a designer. He just goes through and he puts everything and yeah, it doesn't matter if it's so much the grab. He comes up with the ping files and whatever, and then we have our front end Unity guy, and he just plays with prefabs. So he knows exactly how to launch the prefabs, but he doesn't really get involved. And I mean, it's very easy for him to create the prefabs and plug them right into the architecture. The actual these are not so coupled to all the Unity game objects. So it's a nice flow. So we have someone who designs stuff in Figma. They send the graphic elements. We have a person who puts them into sprites, makes the prefab. Like I said, no big programming. It's mostly just UI piece of it and the visual pieces of it. And then that gets handed to our backend developers who it's kind of like a typical way like a web page is divided, right? You got your front end and you got your back end. I think this architecture keeps it nice and separated that way.
cool.
Cool.
So I guess we have questions about source control. Like, what are you using for this?
Oh yeah, yeah. So it's basically Git and GitHub. We've used GitLab before, which I've liked a lot. GitHub has become kind of de facto. I think the big one for Unity people, or like I like a lot, is Git Kraken as far as like a client tool.
Mhm.
So it's been a really nice one just to easily see because people in Unity likes to see visual elements. So to be able to have like a visual Git tool to see the different commits, see what's been changed from commit to commit, I think that's been really helpful.
Mhm.
But yeah, GitHub's nice. I think the big problem with GitHub is just doing the Unity builds. We have the Git hub. These are called actions.
Didn't get it. Yeah.
Mhm.
Is it? Yeah. And I didn't do the build tool this time. That's a whole another skill set. But to really have the different, we have. I'm trying to think. I think it's called game.ci. Maybe is where we got the images from for the Git actions. So we can do. So as soon as you commit, do a commit, it'll do the build, create the APKs, and then anyone in the company can pull the APKs from those different commits to test them, and they're all traced back to that commit. So having an automated build tool is just like this, the CI/CD pipeline. It's just I think extremely critical, right? Because you're not giving people like APKs. Oh yeah, I tried this one, right? They can go right away to all the bins and tell me which code. And we have each ticket we have in our system corresponds to a branch, which corresponds to a build, commit build.
Do you
So
do?
it's really easy to trace everything through. It does seem like overboard for small projects. Like I said, once again, you'd be surprised how much you get yourself in trouble by not having these tools in place. And once you're used to them, it's kind of just transparent, right? It's not like you have to put a lot of time and effort into keeping them up.
Mhm. Do you do anything with like submodules? Like you mentioned branches, but I don't know if you do any like crazy stuff like that with Git or.
Yeah, I did before. So, one problem always becomes is let's say you have this game that has a core and you want to do a derivative of it, and basically you want to use your core code. Um, so I think I'm trying to get a good example of that would be, um, but yeah, so then you would have your Git submodule, which is the problem with is just Unity on that one. I really struggled with trying to figure out how you have one repo with its own meta files and it's being inherited by another project that has its own created meta files, but doesn't know the meta files that you're pulling in from. So I had some issues with that one. And if someone can get that to work really well, let me know. But otherwise, just to put the services in their own packages in their own repo was about the closest I could get. So then you could pull them in with Unity Package Manager, and they became like their own little modules versus the entire core app.
Yeah,
and that
I'll
seemed to work a
definitely
lot better.
I'll definitely underline that and say packages are the way to go these days. Like they're
Yeah.
so much easier than submodules.
Yeah, I'm on a project a year ago that had a bunch of submodules that was a nightmare for everybody. And then I'm on a project now where we're using custom packages, and it's just like, don't worry about it.
There you go.
um, yeah, I think we really need to have a talk on build systems here.
Yeah.
Like I keep talking about, it's like the missing. I don't think we've ever had one. I'm so curious because I've seen so many different systems and recommendations. So I enjoy hearing about what your solution is so far, but I'd like to hear what others too.
Yeah, Unity has a couple of their own things. I forgot what their Unity system's called. It doesn't even use Git. But anyway, and I've even contacted them. I said, I just want a build manager because actually the problem we had, and I don't mean to tangent on this one too bad, but if the project gets so big, GitHub doesn't, it just blows up. It says, it's too big. Because basically we're bringing in all of the Unity and all of the Android build tools in to the container. And then a lot of times, sometimes it'll blow up too big I think there's like something very small limit for what GitHub can accept. So we've had that issue before. And then you have to have your own AWS solution or your own cloud solution of some type. Gets into
Like Unity Cloud Build, I think only builds like Mac, like ILCPP. It won't build Windows.
Yeah.
Like there's weird things like that.
Mac and iOS.
Right now we're building Android and Windows. We do our cloud stuff, yeah, or build stuff.
Cool. What other questions might people have for Barry?
Some good discussion about build systems and source control. We should definitely do a talk on build systems, which is a good segue. If you want to give a bug talk, you should contact us. It's literally that easy. It's we're not that professional.
Yeah, it only took me 5 months of grueling testing to get through. Not kidding.
Yeah. Put you through the gauntlet.
It was all good.
Yeah.
These are good questions though. But people are into. Yeah, I figured people pretty much knew a lot of these topics. Maybe they just wanted to see it all put together or review how to do with Unity, because a lot of this stuff is pretty fundamental if you do a .NET project.
Odin Kong has a question about what parts of Unity's default architecture do you find useful. It sounded like you were using additive scene loading with a manager scene or a init scene. Where does the line get blurry between your architecture and Unity's default architecture?
Yeah, so I think the big difference, good question, is the big difference is like the usage of scenes. I think in the past I would have this scene, and then I'd have all my game objects, and I'd just be turning them on and off to deactivate. And that's a pretty common way. We just kept getting messed up with just transitioning scenes. We wanted certain transitions to look a certain way. We wanted things, certain game objects not to be destroyed. And there's ways of doing all of this, right? And you can even have two scenes open at the same time, right? But I just got into whole trouble with just, like we said, with the code control, repo control, with just how do you do diffs between commits and all that stuff. It was very difficult. Even though I could see some of the advantages. So that's where I kind of broke through. I think the Finite State Machine kind of takes over where you'd have some type of a scene management. Otherwise programmatically bringing up in and out of prefabs. I mean, that's just more of a user decision for Unity more than, a big change up there. Otherwise, I think a lot of it is just maybe doing things, getting away from making sure everything's not mono behavior, making sure everything's not running on the main thread. How do we go about doing this? Taking advantage of some of the things that I don't know people necessarily do, the package manager packages, the Unity assemblies, just to divide the code up. I think that's and necessarily that doesn't really diverge from what Unity presents. I just think there's some of the stuff that maybe people don't use as much as they should. I'm trying to think of what else I actually have that is so different. Maybe and the model view controller, just to kind of divide up the code, I think is also just a good thing to do. Here, let me say, I think I have a slide that kind of. I mean, otherwise, I think you need to do, you can easily do events with that. Whenever you start a .NET application, like I was saying, it goes right into the model view controller and that whole feeling of it. So I just try to mimic that as much as possible.
Yeah, it's like a through line in UI design across disciplines. So it's like there's got to be something to it if everyone's kind of doing something like it. So
yeah, I know web's kind of changed a little bit to the MVVM, but I still like the traditional one for Unity.
cool. I guess we should probably wrap this up. It sounds like we're reaching the end. It's already 8 o'clock. So yeah, thank you again, Barry. This was awesome. A ton of fun. Looks like people really enjoyed it. So
Oh, good,
thanks.
good. I guess as much as architecture can be fun, right?
I think it's fun. I don't know. Some people,
very good. Very
some people
good.
in the chat think it's fun too. So
No, that's really cool.
Yeah, I wish I could see the chat, but I didn't want to mess it up with the presentation. Everything else.
Don't worry. It's just all
Okay.
people making fun of you. It's no big deal.
No, it's
That's
kind of
much-
funny
I'm kidding,
because there's one Unity group user, Jesse, who's like all about finite state machines. Talks
Awesome.
all the
Yeah, so
time.
he's
And so,
very
like,
excited.
he-
when you...
he's very excited. You've kind of like vindicated him.
I'll become out of the t-shirt later.
Yeah.
Yeah, so awesome segue. Like, he was our speaker last month, and the talk is up on YouTube. And this talk will also be on YouTube in a couple days, depending on when I can get around to doing it. So definitely check that out. It's youtube.com/Boston Unity Group. Yeah. And again, if you have a talk you'd like to give or a talk you'd like to see at Bug, get in touch with either Chris, Elliot, or myself, and we'll set that up. And yeah, we'll see you next month, which I believe is the 26th. So October 26th. There it is. All right.
Very cool. Yeah. Thanks, Barry. And again, yeah, anyone has suggestions or wants to volunteer for talks in the future, ping us. We're always open for that. Semi-professional way.
Yeah. All right. See you, everybody.
All right.
See you guys.